Okay, so this is going to be a walkthrough of the evolution of the living Earth data tutorial. So we're going to just show you how to get the data for the practical, and then go through some of the steps for processing it, and I guess importantly displaying it. And this should enable you to basically write the report about CO2 and pH for this part of the coursework. So these are kind of data that we're going to be working with. We've got CO2 data, which are these kind of data here, and we've got ocean pH data, and I've plotted them up here on a single graph so we can compare the two data series. But with the same data series, we can also look at that data in a number of different ways. We might zoom in and look at maybe some of the annual cycles rather than looking at comparing long-term trends. So we might want to adapt our plots to try and kind of best demonstrate the thing that we're discussing in our report. So this is kind of one of the places we're going to try and get to, and this tutorial or this video tutorial will go through how we get to this from just the data series that we have. So if we just have columns of data of pH and CO2. Okay. So I'll just close down that. So this is I guess the learn page. So just go out. So the learn page should look something like this. So if you head over to environmental chemistry practicals and then scroll all the way down to the bottom, there's the Excel and Word practical / tutorial, which is what we're going to be doing now. And the files you'll need are in this folder here. So if you click on that, and the two files we're going to be working with are this CO2 Mauna Loa and this ocean pH from the Hawaii Ocean Time Series. So if we just click on one of those, that shows us the data, but we don't kind of want just to be able to look at it like this. I guess we could highlight the data and then copy and paste it, but there's quite a lot of it, so that would require lots of scrolling down. So what we're going to do is we're just going to save those files. So if you go back, go back. That's not allowing us to go back. So if we just hit files back here, it'll take us back. Okay, and then rather than just clicking on it, if you right-click and then save link as or save target as, this will allow us to save this text document someplace on our computer. So if you're working on kind of university workstations, if you save it to the computer, it's the local disk, then when you log off, then that file will be lost. So you'll have some file space, an M drive, so where it says Thomas6 here, that will be your username. So if you just click on that and save that somewhere for now, just save it here as this text document, and save the ocean pH data as well. So open, actually save link as, that was it, and you can see our first file is there, so we'll just save this one as text document in there. Okie dokie, that's pretty good. So what we'll do now is we'll go into Excel and we will open those files up. So if you just go to File, Open, and we'll browse my PC to find them, go to where we save them, and you can see that they're not there. You scroll down, you can't find those files anyway, and that's because it's set to all Excel files, which is wrong. So if you do all files, you can now see all of the files in this folder. You could maybe even link it to just text files, I think. Is that all text files? There we go. And that should see now the data we want to get. So if you just select one of those, you can see that it's showing you that there is some data in there. Hit open, and now because it's a text file and not an Excel file, we need to tell Excel where to put, which cells to put kind of data in, where to split it into columns. So we make sure delimited is ticked up here, hit next, okay, and we've got tab selected. You can see if tab wasn't selected, it wouldn't split the data up into separate columns, so just make sure tab is selected and then just hit finish. Okay, and that gives us an Excel spreadsheet where the data is split into separate cells like that. Okay, so the next step is to open up the other the data set. So open that, and go to browse, and it's taken us back to where we were before, so we'll just select Ocean pH, select that, and again it's tab delimited, and you can see it split it into columns based on where there are tabs in the text file. Hit finish, and that's opened up another file. Okay, so what we need to do now is copy one version of those data into the other file so we can have both sets of data in one Excel spreadsheet. So you could just use the mouse to highlight all of these data, and that would be tedious and horrible. But the practical asks you to experiment a little bit with just using the cursor keys. So I'm just using the arrow keys to move the selecting cell around. You should be able to see that doing its thing here. And if you hold Shift while you do this, so I'm holding Shift, you can see that it highlights as it kind of moves around the spreadsheet. Like that. Okay. And if you hold down Control, it basically jumps to the edge of blocks of of data. So if I was to hold down Control and if I was to hold down Shift and then go across one, so I've highlighted it, and then Control Shift down, that's just highlighted all of the data. Okay, if you've got really huge amounts of data with spreadsheets like this, using the arrow keys like that and the Control and Shift key can save you a huge amount of time. So I'm going to copy that. You can kind of right click and go to copy, or you could just press Control and C, and then I'm just going to go to the other window, and I think it's View, switch windows, and then go to the other data set, and then I'll go to some other place in this file, and then I'll just Control V, and that's pasted in the pH data into this CO2 data here. So now I've got one spreadsheet with all the data in. I'm going to save that. So I could just save this as CO2 Mauna Loa, but I'm going to save it save as, give myself a new file name. Now I should point out here that you could carry on saving it to your M drive or your kind of networked drive, which will be nice and safe and secure, or you can save it to your your university kind of cloud storage on Microsoft OneDrive, which is being slow. So I could save it on my OneDrive here, which is so let's give it a new name. It's the CO2 and pH merged data. Okay, and importantly, I'm now going to change the file type. So if I saved it as text and I did some work on it and made some graphs and added some Excel formulae, if I then saved it, it would get rid of that and it would just save the numbers in all of the cells, and any graphs would be completely lost. So make sure that you save the file type to an Excel workbook. Okay, and I'm going to save that. There we go. So I now have got a new Excel spreadsheet, and it's got all of the data that I'm going to be working with for the practical. So the first thing to do is, in the practical, we ask you to plot up some graphs, and that's very, very simple and straightforward. We'll just plot the CO2 graphs. We'll work with the CO2 data first. I'm just going to highlight all of those data. So with the arrow keys, I'm just going to press Control Shift across and then down. That highlights all the data, and then to insert a chart, I can just go to Insert and Charts, and I'll just have a scatter plot, standard scatter plot, and that's placed my scatter plot down here. Now, annoyingly, it's placed out at the bottom of the page. We're in row, I guess 600 and something. So I'm just going to move that to the top, okay, by cutting it out. So that's Control X, Control X, and that's cut it. And I just move to the top of the screen, and or the window, or the website, or not the website, the workbook, and Control V, and then we've got our lovely thing up there. Okay, so the first task in the practical is to start playing around with this graph to kind of alter its appearance so we can kind of see some more of the detail of the data. Now, the first thing you'll notice is that most of the data are kind of up here. I'll just give this a little bit more bigness so we can all kind of see it here. And you can see now actually the size of the symbols of the data was actually hiding some of this little wiggles up and down here, which we weren't seeing before. So we need to think about what size we're plotting our symbols. Is that hiding any variability in the data? But the thing that really stands out are these outlying data points down here at the bottom. Ooh, undo that. Which are set at, it looks like, a value of -99. You can see one of them there. So what this is basically it's a missing data identifier. So in that particular month, no data were collected. So rather than put a 0 in, because that's a feasible concentration that could exist, and a computer might see a blank space and think a 0. So rather to basically to make sure that when data are read in, that there are no mistakes made, quite often kind of basically fake numbers are put in that cannot possibly be correct, and there's no way that you could have negative concentrations. So what we could do is we could go and look for all the data and delete all of the data where there are these -99s just by highlighting them all and pressing delete, and you can see some of the points disappearing down the bottom. But finding all of those in this long list of numbers would be a bit tedious. So rather than undone that, rather than searching for them individually, what I'm going to use is basically use the sorting functions of Excel to find them all. So first step, highlight all of the data, and then if I go to data and then sort, okay, I'm going to sort by the CO2, sort by values, smallest to largest, and that should place all of the -99s at the top. Okay, so I can just delete all of those. Actually, if I go to delete and shift cells up, okay, that's got rid of all of those, and those points on the graph now have disappeared. But you might see now that some of the dates are now not in the right order. Okay, so we need to remedy that. So again, we'll just highlight everything and we'll sort, and now we'll sort by the date, smallest to largest still, and there we go. Okay, so now we've done a little bit of, I guess, data filtering. We've removed the missing data points from our graph and our data set. So I guess this would be a good point to save our data file, just to make sure that if anything goes wrong, we can recover information. So there we go. Let's go to File and then Save, and it'll save this file name here. After a while, it might be useful to change the file name, so you maintain a version of the work which was maybe halfway through, in case there's a kind of a catastrophic loss and data corruption, which can quite often happen with Microsoft products. But anyway, so now we've got our graph. We need to think about, can we change this to make it kind of look, I guess, not necessarily look better, but show some more detail of the variability in the data, or show a particular thing in the data. And the first thing that stands out to me is that there's this kind of large, we've got a scale from 0 to 450, and then our data are only really going from 300 to 400. So we could expand the vertical scale to allow us to show some more of the variability. So if we just double click on the axis, okay, that brings us this formatting pane over to the right here, and now we can basically choose some things about our axis. So we could change the appearance of the axis. So we could change maybe the line of the axis to, rather than being grey, which is boring, we could maybe make it nice and bold. We could think about things like that, making it different colours and all this kind of fancy stuff. But the important thing is this thing that looks a little bit like a histogram, or I like to call it a skyscraper for no reason. This allows us to change some of the parameters of the axis. So we're going to change it. If we change the minimum value to 300, okay, you can see that changes the scale quite dramatically. Okay, we can also change the numbering on here. So rather than every 20 parts per million, we could maybe change it every 25 parts per million. See if that has any kind of, I mean, that is actually not making any difference. We could see if we can have some tick marks, okay, next to those numbers. So we don't have any tick marks at the moment, so we'll have some major ones, some big ones inside. We can see those there poking out now. We could do the same thing with the horizontal axis. We could make that look nice. Some more, yeah, and then go back and maybe give us some tick marks inside. Okay, so it's now looking a bit more presentable. The things that are missing, are the axes labels. So we can add those either with this plus symbol here. We could add various kind of things up here, or we could use the, if we've got the chart selected, in the Chart Tools Design tab, there are Add Chart Element things up here. So we can add axis titles, so the primary horizontal one, and we can have the primary vertical one. Just label those year, and we could change the axis title here to CO2 in parts per million. Okay. Now, you can, if you so choose, highlight parts of the text there and go to, I think, is it format? Well, you can certainly, once you've got the axis title highlighted, go to home and do things like maybe increase the font size somewhat. I think if you check this little arrow down the bottom here, that gives you more settings which you can change the font. So I can maybe change that to, I've highlighted, to a subscript. Click OK, and that's made in CO2 ppm. And I can, of course, see that's been a grey colour, so I can just change that to black. So I can see CO2 ppm there. Make my values a bit bigger. Change the font if you so choose. But you can mess around quite nicely with the appearance as you see fit. Now, one of the things that I particularly hate on Excel graphs or any kind of like data are these grid lines. Sometimes a grid line is useful if you're trying to see very small changes in data over a wide kind of spatial scale on your graph. But in this case, these grid lines don't actually help us interpret or see the data in any way. So I'm gonna just get rid of those. So I guess you click on them, and then the formatting pane changes to the options for those grid lines. I should just point out, if there are chart elements which you can't click on because they're obscured by things in front of them, or you're not sure what's in your plot. If you go to this tiny little grey triangle, and if you click on that, it highlights all of or it tells you all of the things that are in your plot. So there's a chart area, there's a title, we've got horizontal axis, we've got the axis grid lines, you've got axis titles. So click on those. As you click on those individual things, you can see that the thing gets highlighted in the graph, and then the option, the formatting pane kind of changes to be relevant to that thing. So if we just go to the grid lines and just click none, and then I can go to the other grid lines and also go none. Okay, so that means that I've now got rid of those horrible grid lines which don't really help me interpret the data in any way. One thing that you should do though is mess around with the symbol shapes and sizes, because you can see there is some variability we're seeing in the data here which are slightly obscured by these big blue splodges. So if we select the data, we can then go to this paint can, and if you select marker and then marker options, you can change the shape from circles to maybe squares, but importantly, you can change the size of those. So we could make those smaller. We could maybe change the color of those. So those are maybe solid filled in. We could change that to red. Everyone likes red, right? And then maybe not have a border around each point. So no line there. You can see now we've got a nice series of CO2 going up in red there. So that's one thing that you should have a play around with. Now another thing that you can do is add another data series to this graph. So if I wanted to compare CO2 change through time, with ocean pH, okay, we could just have one graph and then another graph of pH, and we could compare those, put them next to each other in the document. But it's much more easy to compare the data series if they're actually on the same graph. So one way of doing that is to go to click on the graph, right click on the graph, and go to select data, and then just click add a new data series. Okay, and then it gives you the option to give it a new series name. So I'm going to select the series name from somewhere in the spreadsheet, pH, or the cell that the words of the title I want is in there, and then I can select the X values. I'm just going to select all of the time values. So I'm holding Control and Shift, and that highlights all of those data. And I'm going to, why is that not working? Select the Y values, which would be all of those data. Okay, and that has kind of worked. Looked like it didn't work, but if we just click OK, and now you can see that the data are now in this graph here. Okay, they're not, you can't see them, but they should still be there. So if we actually go to this little triangle here, and we look at the list of things in this graph, it says that there is a series called pH, and it's in this plot somewhere. Now the reason we can't see it is because the values for pH, if you can see over here, are around 8, and our scale only goes down to 300. So if we were to change the scale, just reset that, okay, you can see our pH data are down here. So I'm just going to undo that. Another way of kind of fixing this problem is to basically to plot the pH data on a separate y-axis that will go over here. So that's what we're going to do now. I'm just going to plot that second second y-axis. So if I go and select the data series, I'm going to select from this little triangle up here, select pH. Now that pH data are highlighted, and then you can actually see which data is given. This these coloured triangles here, coloured triangles. They're coloured rectangles highlighting the data that are being selected in this plot. And now if you go to the this I guess bar chart or skyscraper option, if you just click secondary axis, that creates a secondary axis over here, and now we've got the two data series plotted on the same image. So that's one way of doing it. I'll just quickly show you another way. So I'll just undo all of that kind of stuff. So now we only have the one data series in our redo the color change. So if we look now, there's only the one data series in this plot. So I'll add another data series to this plot in another way. So one way is to highlight our new data we want to put in. Okay, and then I'm just going to make a plot of that in the same way as before. Okay, there it is. I'm just going to copy that. Let's cut it actually and move it up to the top. Stop here. Excuse me, someone is ringing the phone, so I'll stop recording for a bit. Okay, so that phone call somewhat interrupted me. Right, I was going to show a different way of adding another data series to a kind of a plot like this. We can do that by making another graph. So I've just highlighted the data there for the pH using the arrow keys and the Control and the Shift. So I'm going to insert a chart, my scatter plot, and that has given me a nice new chart here. Now it looks horribly formatted and all this kind of stuff, and that's a bit disappointing. But what I'm going to do is I'm going to take the original chart, this one. I'm going to copy that. So I'm just pressing. I guess I do that like this. Copy. So I've copied the whole chart with the axes and the titles and the data series and all of that kind of stuff. And then if I go to the other chart, I'm just going to paste into that. So I could just go paste. And that's pasted all of the data from that one into this one. Okay, and all of the formatting from the original one has been copied over into my second graph here. Now it looks like that's kind of got rid of the pH data, but if I actually go and have a look at what's in this plot, that's series 2 here. If I kind of highlight that, you can see that that's highlighted the pH data. So it's in this plot somewhere, we just can't see it, and that's because it doesn't have a secondary vertical axis. So that gives us it that way. Okay, if I kind of make that, give that bigness. Now, okay, I can open that up to like this, and we could play around with these data as well. Okay, so that was the how to get two data series onto the same plot. So I can just kind of start to make that look a little bit more presentable. So I could go to the line options, make my line black. Yeah, the same kind of things as before, and maybe go to the tick marks and maybe have them on the inside so it kind of matches both sides there. We can mess around with it. We can actually change the axis title now, so it's actually a comparison on, maybe that's how you spell comparison, I'm not sure, of atmospheric CO2 and ocean pH. Okay, spelling might be wrong, but so the title is not just saying a graph of CO2 pH. It's actually telling us something about what we're trying to show here. So if I was kind of maybe showing the annual cycles, I'd maybe give it a title saying annual cycles in, so that it describes the thing that I'm trying to show rather than just the things I'm plotting. So I could change that to comparison of trends in, okay, because I'm looking at the long-term trends. Okay. I'm missing an axis title here, so I can add myself. Just undo what I've done there. Undo. So I will add a axis title this way because that allows me to add the secondary vertical. So this is now just ocean pH, and I will give that increase the font size in that so it kind of matches the side. Okay, so that's all pretty bold because I need it to be bold. What's the size of the other one? 18 and 18. Okay, that's pretty good. So the next bit of the practical asks you to think about adding some trend lines to the data. So we could maybe think about going to the pH data series and adding a trend line. So there we go. We can see it's given us a nice trend line through the data. Again, we could get rid of this. We could go to the, we could change the appearance of that, so we could make the line a bit thicker. We might want to change the color of it. So if you've got two data series like this, it's a good idea if you're using color to try and group two colors together. So kind of things like trend lines or summary means of one kind of group of data kind of all look kind of like they're part of one group of data, whereas the other one looks part of the other. So in this case, maybe if we make all the pH stuff kind of reds and oranges, and if we make all of the CO2 stuff, we could change that to marker options. We could fill that in maybe blues. Okay, and we could do the same thing to the text. We could maybe make the text oranges over here, and the text for these over here. We can make the text kind of those blues. Okay, so that kind of links together the axes with the data a little bit more visually clearly. If that's a thing you're into, you can also change the axes colours from black. We could add trend lines by just adding a trend line using add trend line. There are a number of different options for adding trend lines. If we go to the CO2 data, we could maybe think about adding a trend line to that. Actually, that adds a trend line across the whole data series. But if we select that trend line, there are a number of options that we have for that. Oh, it's pretty annoying that this is. Yeah, let's get rid of that. Oh. So we can have a linear. We can maybe think about putting an exponential in, a polynomial. There's no reason to use any of these other kind of maths curves, an exponential or a logarithmic or a polynomial, if you don't have a physical, reason for thinking that there is a specific kind of mathematical relationship between the data series. So there's no, it's not, although it looks like it's fitting the data a bit more correctly, unless we have some kind of understanding that it should be a polynomial relationship between these two, we shouldn't use it. So a linear is maybe not accurately describing all the variables in the data here, but it might not be entirely correct to use a polynomial or even a power function through any of these data. What is sometimes useful is to use the moving average, because you can see that is basically averaging kind of the points as we go through, providing some idea of like what we can see in the annual cycles. Now, I'll just show you a little kind of feature of Excel, which is basically something bad about it. So, and it's not actually a very good idea to use this moving average. So what I'm going to do is I'm going to zoom in on a bit of these data. So if we were thinking of comparing just the CO2 and the pH data, if that was the comparison we were looking at, there's no point in showing all of these data over here because we have no comparison with pH. So I'm just going to change the horizontal axis to zoom in on a little bit of this data series here. So let's go from 1994, oh, not 1940, 1994 to let's go to 2015. So, okay, so that's showing where we have kind of, I guess, both the sets of data to compare against each other. So if you look at the trend line that's in between these points here, it seems to follow the data quite nicely. I'm just going to add in another line here. I'm going to add in a line that goes in between each of the points. So this isn't going to smooth out the variation like the moving average will, but it'll show the data. So if I go to click on the data, I see this is one of the things where I can't actually click on the data series because the trend line is in the way. So I'll actually go over here to the CO2 data series, and I will just add a line, a nice solid line that goes between each of the points. So I'll make that blue, the same color as the data points, and you can see that closely follows where the trend line is going. So if I select the trend line now, CO2 trend line, and go to the options bit, the little skyscraper, I can change over here. I can change the change the period. So basically, the number of points over which it averages. So as we increase this, you can see that the signal gets kind of smoothed out a little bit more as we're averaging over more and more points. But one thing, hopefully, you'll be able to see is that the position of the maxima and the minima in each of these cycles seems to get shifted over to the right as we increase this number here, the period. And that's because Excel does the moving average in a really, really stupid way. What it does is it basically looks at, looks for the first 7 data points, starting from the left, moving on to the right. It works out the average of them, and then it plots that point where the 7th data point is, rather than the 4th data point, which would be in the middle. So this has the effect of whenever you increase this number, it starts to shift any variability slightly out of phase to the right. So if you are going to use moving average, I recommend that you keep this value quite small in comparison to the density of your data. So we could add one of these moving the trend lines to the just undo that. Sorry, undo. I'll just add another trend line to the pH data series. So I can't add it using this thing because there's already a trend line there. So I'll just add it by adding a trend line this way. Add a moving average, and you can see that this is a lot more noisy. Again, I'll just go and it's given us a second trend line, so we can go through and maybe make that burgundy or orange or whatever. Oh, orange isn't very good, is it? Let's go dark. Okay, so we can see it quite clearly there. Make it. So we can make the period of that bigger. Okay, a little bit. That smooths out some of the noise a little bit more. So yeah, play around with these kinds of trend lines. Do they show patterns in the data? And hopefully you'll be able to see by putting that moving average trend line into the pH data, you can see that the pH data has cycles in it that are of the same frequency, if not as regular in terms of their amplitude as the CO2. So the CO2 has these nice annual cycles. There are also cycles in the pH, but the data are more noisy. Okay, you might want to think about how those cycles compare to each other. What might be causing that? But that's something you can play around with the trend lines. Okay, so the next bit of the practical is to look at this pH data series in a little bit more detail and maybe trying to summarize it in a slightly different way. So we've looked at maybe showing the long-term trend with a trend line. We've maybe put a moving average in it. But we might want to average the data over a longer time period. So maybe split it up into years and then work out the average pH for each year and plot that. So that's what we're going to do now for the next bit of the practical. So to do that, we're going to have to create some kind of table that will be actually if we go to move these up here out of the way. We'll keep this one, just tuck it out of the way. We're gonna create some table which is going to have kind of like the year, and we're going to have the pH average. Okay, we could even spell that correctly. And if we're working out the average using mean, we might also be able to get some idea about how variable the pH was in that year. So we could maybe work out the standard deviation, and maybe even also the standard error of the mean. So basically, how accurate are we able to figure out what that mean is? Okay. So what we could do is we could just kind of write down every year. We could kind of say 1992. That seems the first year, and we could make a little formula. So if we type equals and then the cell above, press enter, that gives us cell above +1, obviously, and then kind of copy that down just by dragging in the corner. Okay, that gives us years down to, yes, I think our data goes to 2015, something like that. Okay. So, and then we could work out the average pH for that year. So if we could type a formula equals average, and then we could kind of go through and we could look through all of the pH data like this that is in 1992. Okay, do that, and then that would give us the average pH for that year. We could work out a formula for the standard deviation, and we could do that, and that would take a long time, as we'd have to manually find the data for every year. So what we're going to do is we're going to use a feature of Excel that allows basically Excel to look through a long list of data and find a particular number and tell me where that is. Okay. And it will then output a number, which is basically where I need to go and look for a particular kind of data point. And then I can use that to calculate, basically place in my average formula up here, say basically go and look here and calculate the average of those data. So I'm just going to move these over, okay, and I give myself basically a column that says cell reference. Okay. So what I'm going to do, I'll just start in 1993 and see why I can't start in 1992. So the formula that I'm going to use is called match. I think it's called match. Let's say it's called match. Yeah, it's called match. So if I type equal match, okay, and then it tells me that there is a formula called match, and then I open the bracket and it tells me the value that I'm going to look up. So I want to look for the number 1993. Okay, so I'm going to look at that value. And I want to look through an array of data. And these are the data that I want to look through. So I'm just going to, actually, I'll just start again. So I'm going to look through Control-Shift, all of those data. Okay. And then if I put another comma, and then I want to look for the number that's just actually less than the first number that is greater than 1993. Okay, so if I close the brackets, hit enter, okay, that brings me back up to here, and you can see that's returned a value of 15. So if we actually look down, we start here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the next number is 1993. Okay, so that's fine with that. I can copy that down, okay, just by double-clicking when I'm hovering over the corner there. I'll just do that again, undo. You can see the cursor changes to this black square, and if you double-click, then it does it. So if we then say pick one of these cells just to check what that's doing, and you can see that it's changed the cell reference to look for 1996 here, but it's also changed the cell reference for what we're looking through down here. Now this is not a problem in this case, but it can be an issue for other things. We want really this to stay looking at this array of data. So to do that, I'll just escape out of here. What we can do is, in our formula, we can add a $sign in front of the part of the reference that we want to always stay fixed. So if I always keep it always looking in column M, it'll always look for, if I put the dollar in front of the letter, the reference will always stay in that column, but it'll allow the row number to change. Okay? And you can switch between kind of the different arrangements of these $signs, whether they're just in front of the letter, the number, or both, by pressing F4. So if you press function key 4, you see it cycles through. This is me just pressing F4. It's cycling through all these nice things. So I want to make sure that it always refers to exactly these cells, no matter what. So if I put a $sign in front of both of them, then that's fine. So if I just to show you that, so if I had put both $signs in front of the 6 and the M here, and oh no, press F4, not 4. Okay, and if I copy that down, okay, you can see that it's always going to refer to exactly that cell and exactly this array. And that's not quite what I wanted. So I want it to be able to change the row number. So, okay. Now, if I copy that up to the first one to look for 1992, the formula throws a wobbly because it's looking for the number just before 1992, and it can't find one because there is no data before 1992. But we know that we want to start looking in the first thing of the array, so we'll just put a 0 in there, and we're good to go. Okay, so now we can use these cell references because these numbers here tell us which row to go and look in to find the data from 1992, and the difference between these. So the difference between 45 and 15 is kind of the number of data points that are in 1993. Okay, so we can create a formula that will, instead of using average, well, we'll use average, but instead of this formula here, we'll use these numbers here to go and look up a particular array of data. So the formula that we're going to use is offset. Okay, so I'll open a bracket there. So I'll be looking through all of these data here. Okay. Well, for all of these data, let's actually do all of these. I'm doing the stupid thing again. I'm using my mouse. You see how annoying using a mouse is? What we really want to do is use the arrow keys. Okay, so that's there. And then we want to look for, I guess the first thing we're going to do is we've told it the array. Now we want to know basically which cell in this array we need to go, which row we need to go down to start our bit that we're going to average. For the first one, we're going to go to the 0. So just pick the cell that's got that 0 in, and then we want to know how many. It says, well, what it wants to know is how many kind of cells across we want to go. Okay, so actually for the pH here, we want to go actually across one cell. So if we put 1 in there, that'll then be working out the pH, or taking the pH data, maybe, hopefully, if this works. And then what it wants to know is how many cells to go down. Okay, so we want to go down to the 15 here. So rather than just put 15, I'm going to do 15 minus 0, because when we copy this down, we want it to be 45 minus 15, 82 minus 45, because that's the number of cells in that year. So if we do this one minus this one, okay, and that would that should hopefully give us the average pH for. Oh, I forgot to. That's annoying. No, I don't want to. Okay. So you'll see that I've not closed out all the brackets fully here. So I've got an open brackets for the average, the offset as open brackets, and I've only closed one of those out. So I need to put another closed brackets in there. Okay. And you can see that's worked out the pH average. Now, we also want to actually work out, because the data for each year aren't nice and even, we don't want to necessarily plot. The average pH in 1992 might not be these data might not be representative of the average time in 1992. or the middle of 1992, because the data might be all in 1 month or not evenly spread for the year. So we're going to just measure the average time in each year as well. So I'm going to add in a new column. Actually, I'll add it in insert here. So I'm going to actually copy that formula back over. Oh, and you see it's not working. Okay, and we'll see why that isn't working in a bit. So I'll put average year. Okay, so if we click on that formula, we can see what it's looking at. Okay. So you can see that as I copied it across, it's copied across these references it's looking for. So I can manually drag those back, okay, where I want them to be. Like that. Press enter. Okay, and you see it's now working out the average pH. And to change the year, we basically, this number here, this 1, we don't want it to go 1 across, we want it to go 0 across, so to stay in this column. I'll put a 0 in there, it should work. Okay, so it tells us actually for 1992, the average time was actually quite close to the middle of that year, so that's fine. So in this case, this step might not have been such a good idea, but so the thing is, we don't want to copy that across. We want to stop that. We want to stop that happening. Okay, we want to stop this kind of crazy cell references moving. So the way to do that is with these dollar signs in. So for the array, we want to always look into exactly these cells. So I put the double dollar signs in there. For the cell references, we always want to look in this column, but we want, when we copy down, we want the cell rows to change. So if we just change it just in front of the N, and again just in front of the N, and again just in front of the N. Okay, save that. Then I'm going to copy that across. So we've got all those dollar signs in the right place. But to make it the pH average, I just need to change that 0 back to 1. Okay. So we can also then just copy that across to the next column, okay, and work out the standard deviation. So instead of using the formula average, for this looking up the same set of cells, we can just type standard deviation dot S, okay, and that'll give us the standard deviation of a sample of all possible pH measurements of that year, so, rather than standard deviation dot P, which would be the population of all measurements that could conceivably ever be made, which is unlikely. Right, so we use dot S. So hit enter there. Oh, and I've done that in the wrong cell. Okay, you can see I've changed the formula in this cell instead of this cell. So because we've got the dollar signs in, I'll just move these cells around. Nothing bad will happen. Okay. So now we've got the average time of the year, the average pH, the standard deviation, and now we can then just work out the standard error as well. So the standard error is the standard deviation, it's going to be equal to that, divided by the square root of the number of measurements. And we know the number of measurements because it's going to be this number minus this number. Okay, so in this case it's going to be 15 for the first year. Okay, and just to complete this, we'll just make sure that those stay in referring to cells in column N, and that stays referring to column in column Q. Close the bracket. Do I want to correct that? Looks like the correction is correct. So yeah. Okay, so that gives us our standard error. Now, sometimes it's useful to plot twice the standard error, so because that is an approximation of the 95% confidence interval of our estimate of the mean. So I'm just going to take that number times 2. Okay, so I'm going to copy the title across and then change that to 2 times. Okay, so now we've got a nice kind of worked out for 1 year, and then to work it out for all of the other years, okay, we can just highlight all of those cells and copy down. Okay, and you can see that's copied down nicely there. Now you'll see that it's not worked for some of the data there. Have a look why that is. We look at the years 1999 to 2002, and I guess 2015, 99 to there's no data in those years. There's no data. It's all gone. No data in 2015 either. So what we can do is, for the moment, we'll just delete those. So I've highlighted them and pressed the delete on the old keyboard there. Deleted those. So now we've got some data where, rather than plot all of the pH data, like we see in this plot here, we can just plot the average pH for each year. So to do that, we can just highlight those kind of X values and Y values. We can insert a chart into our thing. Okay, so now we've got these data. Now, if we wanted to make a plot that wanted to include these data into this plot here, we could quite simply just kind of make them. I guess making it bigger doesn't matter at the moment, but if I take the plot that I want to copy stuff into and copy that, and then copy that into the new plot. So copy Control C, I've copied this, and now if I go into my new data plot, I can go Control P. Okay, and you can see that it looks like it's just copied this across to here, and we can't see our new data series at all, but that's because it's hidden, because it's probably plotted it on the first axis rather than the second axis, because it doesn't know. So we can go into basically the things that are in this chart using this little triangle. Go down to the data series we've just added, which will be data series 3. Click that, and then go to the skyscraper over here and make it onto the second axis. And you might just be able to make out that there are some data points which have appeared. Okay, they're not terribly clear, but we can make them bigger. We can go to our markers. We can go to our marker options. We're going to use some built-in things. Let's use. I guess we've kept with squares, so let's keep them with squares. We'll give them some bigness. Okay, they're grey. We can't quite see them, so we'll maybe change the colours. So we'll maybe have maybe fill them in yellow with a nice red border, and we'll give the border some boldness. Okay, so we can see that those data are now a little bit more visible. Not a lot more visible, but a little bit more visible. We can play around with the order that things are plotted. So they might look like those data are plotted at the back. So if we right-click on the plot, we go to Select Data. We can go to our new series 3. We can actually edit that and change the series name to annual pH means. Okay. Now it's got that. Maybe that's not even how you spell annual, but anyway. But we can change the order. So if we highlight that data series here, you'll see that there are these little arrows here. We can move it kind of down, and that basically actually moves it up the plotting order. Okay. Annoyingly, the trend lines are always on top, so they will always obscure some of the data. And another useful feature of Excel. So now we can see we've got the annual means. Now we've got a lot of data on this plot now, a lot of different symbols and whatnot. So what we can add is a legend, which is like a key. Doesn't really matter where we add it. Add it to the right. Okay, put it to the right there. You can, once you've added it, kind of change the size of it or not. You can even move it onto the plot if you so choose. That, and then make your plot bigness again. Okay, so we've now got a key on our plot now. So it's obscuring some of the data points like that, but it's kind of up to you to position it somewhere sensible, and also somewhere that looks kind of makes most efficient use of space on your plot or on the page in your report. Okay, so we've got the legend in. We've got some data points now. We calculated, actually, if we move this over to here, we calculated these standard errors. We could actually start to think about putting some error bars on these data points that we've got here. So just select the data series. Just make sure that it is actually the series annual pH means. And then if I go to the chart tools design, I can add a chart element. I can actually add error bars. So we can let's just add. It doesn't really matter which ones we add first. Let's just add those. See, it's completely ruined the plot. That's kind of a bit of an annoyance. We'll just add some error bars. Now it's added 5% errors. That's not really very useful. So the first thing to note is we don't really have any errors in the age. I mean, we could have worked out the standard error of the mean of the timing of each year. So I'm just going to select the horizontal error bars. Now, if I can't find those on the plot, I can't click on them accurately. I can just go to annual mean, X error bars, select those, and I'm just going to delete them. So I'm just going to hit delete, and you can see that those horizontal error bars have gone away. I'm going to select the vertical error bars. Now if I go up to the skyscraper symbol, you can see there are a bunch of options. I can have them with like no end cap or with an end cap. Okay, that doesn't really matter to me. I can change the appearance of them. Okay, well I might change them to red because the rest of that, okay, it took a long time to do that. That's fine. I can make them really bold so I can actually really see them. All of these kind of visual things, but the important thing is that we can choose how long to plot these. Okay, so we can give them a fixed value of maybe 0.1. Okay, if we know that the average error is 0.1, but actually we have measurements here. We have kind of data that show you how big these error bars should be. So if I just go back to those error bars, I can choose a custom value for each one. I can specify what that is, and then I can specify separately the length of the error bar above the point and below the point. So I'll just select that and select all those data and all those data. Okay, and click OK. So you can see now that it's added. If I just click off here, you can see that there are error bars that are on each of these data points now. Now the symbols have somewhat obscured those error bars, so I might choose to make my symbols a bit smaller, so I then have to actually go and find the series and change the marker options to maybe not be so ridiculously huge, but there you go. So you can see now we've got a plot that shows the change in pH through time in terms of the raw data and also these annual means. So now maybe the raw data in the background, these individual measurements here, they're not so important for our interpretation. So we could maybe get rid of them, or we could think about making them maybe a bit smaller, or changing the color for the nice solid fill with maybe some transparency. Okay. That is also kind of orange or something like that. So by adjusting the size and the coloring of stuff, we can really highlight the important things that we want to show and maybe reduce the prominence of some things that are less important. Okay. There's one of the graphs which would be useful to have in a report like this. You might think about the things that you're trying to show. This is a good one for showing that the trend, how CO2 changes through time, and how the pH changes in conjunction with that. I should just point out that I haven't saved it in a while, so let's file and let's save. Because there's nothing says incompetence like losing all your work because you didn't save it. Right, so that's I guess another part of the practical finished. The next part of the practical is looking back at this CO2 data. So if we just scroll down, I'll just move the CO2 plot over here maybe. So we put a trend line through this a while ago. So let's put that trend line back. And we might maybe just add trend line. Add trend line, and you can kind of see that it's plotted in blue, which is not terribly helpful. So we'll put it in red with just a solid line. Okay, and you can see here that it looks like the CO2, the rate of change is increasing through time. So it's maybe increasing a little bit slower here, and then the slope increases through time. So it would be nice to be able to maybe investigate that a little bit more rigorously and say, can we actually work out maybe the slope of this change in CO2 or the slope in this CO2 concentration through time? Does that kind of change for each maybe decade? So let's think about how we might do that. So we could kind of make a separate plot for each decade and then do a best fit line through it using the Excel function here. And on our trend line, we could look at some trend line options, which we could maybe display the equation on the chart, which is there, and we could look at the slope of that. In this case, the slope is 1.5. Okay, and then we could see if that's different for each decade. Okay. That would be a bit tedious, but we can kind of bypass making a chart and just use the formula that that Microsoft Excel uses when kind of working out the gradient of a trend line. Okay, so those formulas are slope and intercept. So let's just have a play with those. So if I type, I guess we'll make a little bit of a table. We'll have a table of slope or gradient and intercept. Okay, and then we'll just have a different tag. So it's going to be all time. So I guess all, and then we might do it for an individual decade. So we could do it for the 1960s. Okay, so let's first of all do it for all. So if we just equal, and then we type our formula, which in this case is slope, and then we just put in the data. So the CO2 data for the known y's, so these are the y values, those are just going to be our CO2 data. So I'm just using the arrow keys, Control and Shift to do that. I've typed few. Oh, of course I've typed too few. Okay, because it wants the slope, the y values, and it needs the x values as well. So our x values will be all of these data. Okay, and I've gone over there, so I'll just hold Shift down now and press down, and that allows me to adjust the height of that selection there. Okay, so I'll type Enter, and I could do the same for intercept. So intercept, equals so it told me that's what I want to do. So intercept known y's, which are these data, and the known x's, which are these data. Okay, and hopefully you'll see that those values that I have just calculated, 1.5 and minus 2,600, are the same as what Excel has used. So we could manually do that for each decade, and we are going to have to do it manually for each decade, because we're going to use a fancy kind of feature of Excel, which doesn't just give us the slope and the intercept. It also gives us some statistics about how confident we are in the kind of these values for gradient and intercept. Okay, so this is this feature of Excel, which allows us to do what's called an array formula. So what we're going to do is we're going to produce, rather than just one answer from a formula, it's going to give us a block of data. It's going to give us a 2 by 5 grid of data. So if you highlight a grid of cells, it's important that you need to, before you start typing, that you've highlighted the range of cells you want the answers to go into. You can't just start by clicking one cell. You've got to click a range of cells like that and hit equals. And then the formula that we're going to do is basically linear regression. So a linear estimation. So it's lin est. Okay. And we're going to open the brackets, and then we're going to let's just do it for the 1960s. So we find all of the data from the 1960s. And annoyingly, that this formula does not allow us to use this lookup function, this match, this offset that we used before. The known y's for 1960s, so we find the first data for 1960, which is here, and we scroll, copy down, not copy down, just highlight down to the last 1960, which is here. Okay. And then we want the known x's, which will be from here all the way up to here. Okay, and the next things it's asking us to do is do we want to try and force the best fit line to go through 0? Okay, and in this case, 0 doesn't really have any meaning. It's kind of a 0 concentration in the year 0 AD, which actually doesn't exist. There is no year 0 in the AD BC year system. So we'll because we don't want to force our line through 0, the intercept is effectively arbitrary. We will put either the word true, or we can put 1 in. Oops, 1 in for true, and then we're going to put another 1 in because we want to return these additional statistics. So put 1 in there. I'll close the brackets. Now, when we press enter, we don't just press enter. Just pressing enter will not work. You have to press Control and Shift and then Enter. I think it might just be Apple Enter or Command Enter on a Mac, but just Control Shift Enter. When I press that, you'll see, first of all, you'll see that it's produced an array of data, hence the array formula. And you can see that it's produced these curly brackets either side of the formula. Now you can't add those curly brackets in using the curly bracket keys. Those are basically a thing Excel has put in to say that this is an array formula. So what we have here, we've got this array of data, and if you're unsure about what all of these numbers mean, you can go to the formula up here, and if you click on the formula, it'll give you an option to basically get some help. So if you click on that, then if you wait a really long time, then the help will pop up, and it will tell you what this is doing. So it's kind of working out the equation y equals mx plus c, or y equals mx plus b in this case. This is the value of the constant it's giving. All kinds of information it gives us here, and it tells us that it's going to give it out in this kind of grid of data here. Okay, so we've got these variables mn, which is the gradient, mn plus 1, which is the I guess the next variable in the regression. So this can do more complicated regression than just a straight line, hence the somewhat tortuous syntax. But the important things are this SEN and the SEN minus 1. So these are the standard errors of the estimates. So we've got I just we've got this number here. That's the gradient, and this is the standard error of the gradient. This is the intercept, the standard error of the intercept. We've also got the R squared. We've got all kinds of other fancy stats in here. So you'll see that this gradient is a lot less than the average gradient, and that kind of makes sense because we're looking at this period in the graph down here, where we've got in the 1960s the gradient should be on average lower than the overall gradient. So we could now just add in the slope there and the intercept. Oh, escape. That's equal to that. Okay. Now we could make an extra column in here. Let's make an extra column in here for the error of slope. Okay, which is equal to that. Okay. Or we could make that 2 times to encompass, get a better approximation of the 95% confidence interval. So that's now 2 times the standard error of the slope. Okay, so we can do that now for each decade. Now, annoyingly, because we can't use this fancy cell referencing that we used before, we're going to have to do this kind of manually. But I'll just do it for a few of the decades. So again, highlight our array of data equals linest, and then we've got the known y's, known x's. So let's go to the 70s now. So our known y's for the 70s will start here and go down to here. And our known x's will be these values here. Okay, and then our constants, I'm going to have 1 and 1, close brackets, Control Shift, and Enter, gives us those curly brackets, and hopefully that will have now given us these data here. So we've got the 1970s, and this is going to be equal to that. That's going to be equal to that, 2, and this is going to be equal to that. Okay, so you can see that we the gradient here appears to be steeper than here. Okay, the important thing is that is it steeper outside of the error? Is there actually any noticeable change in between the 1960s and 1970s in the slope of these lines? So that's the real question for the next part of the practical, is basically to do this for each decade. Will this copy down? No, not. We can just change that to 80s, 90s, and 2000s. And we could actually put in the 2010s in. We don't have all of the data for the 2010s. We only go up to, I think, 2014. But you could do that for all of these these decades. So I'm going to do this just now. You might want to skip forward in the video. I'll just go through kind of again now. So equals nest. I'm going to find our y's for the 80s. No, too far. 89. Yep. And our y values. Sorry, our x values. Those. And then 1-1. Close brackets. Control Shift and Enter. Important to do that. Curly brackets appear, and then hopefully we should have. Oh, you see, I was a bit of an idiot. So this is what happens when you don't highlight a grid for answers. It only gives you the answer where kind of you've highlighted. So what we'll do is we'll do a bit of a sneaky cheat. I'll go to the formula. I'll copy all of the text. So Control C, okay, because I can't alter part of this array. I can't just change anything in there, which is annoying. So I'll escape out of that, and then I will highlight everything that I want. So I want it to open in there, and I will now paste that in over itself, which looks like it doesn't make a difference, but it does. And now press Control Shift and Enter, and then we get, you see, it doesn't change the first number, but it gives us these other estimates. So this is the 80s, so equals to that, enter, equals to that, enter, equals to that, enter. Okay, that's what we were doing. Okay, not make the same mistake twice in a row. That would be foolish. Nobody likes being foolish. So go down to the 90s now. Okay, 90s. Everyone likes the 90s. All kinds of fun things that happen there. Comma in, so the X data in, comma 1, comma 1, close brackets, Control Shift and Enter, and that gets me my things up here. Okay, so here you can see that there doesn't appear to be much change between the 80s and the 90s in terms of the slope, at least the rate of change of CO2 through time. I think I missed out putting the times 2 in there, didn't I? Times 2 and times 2. Okay, all those others have got the times 2 in. So we'll just do the last two quickly. I guess another opportunity to save, so I'm just going to Control S and save. Always remember to save. Save your McSave face all the time. So 2000s now. Go 2000s to 2010. Come on. And we get there. That's the last one, 2009, comma. There we go. There. Comma 1, close brackets, Control Shift and Enter. That was fun, wasn't it? And I just lastly copy those, not copy, just highlight all of those, sorry, and then linest, open brackets, and then we're just going to go down to the 2010s and do all of those. Ooh, no, too far. Okay. 1, 1, close brackets, and now Control Shift and Enter. There we are. So we'll just copy these or just reference these. So we've got the 2000s one, and that's going to be equals to 2 times the error in that, and this is going to be equal to intercept. This is going to be that equals 2 times our that. And this is going to equal the intercept. Let's go down to the intercept, right. Okay, so I will I'll save that again. So what we've now got, we've got a table for each kind of decade. We have a slope and we have an error in the slope. So we could think about making another column, which is when is the midpoint of that, so we can make a plot on these graphs here. So the point, I guess the point of this part of the practical is for you to think quite carefully about what's the best way of showing these data. I mean, it could just be a simple table like this. Okay, and we think about because this table here, or just all of these, clearly shows that at the beginning in the 60s, although the 60s wasn't the beginning, there was things before the 60s. In the 60s, there was a lower rate of increase of CO2 in the atmosphere per year, so great, I guess 0.8 parts per million per year, whereas in the 2000s, we were more towards 2 parts per million per year. And we can compare that change with the uncertainty of each of the kind of the decadal averages. So we can see that it has changed outside of the uncertainty. See, one point about these data is that you can see that it's quoting all of this to many significant figures, but actually really the uncertainty on this number is 0.13 really. So there's no point us really showing all of this uncertainty, this precision out here. So if we highlight all of the data that's the value and the error in that value, we can change the number of significant figures that it quotes, or decimal places in this case that it quotes it to. So I'm going to just reduce the number of decimal places, okay, down. So we're now quoting the precision that we're quoting in our slope is kind of appropriate to the kind of size of our uncertainties here. So this is now a little bit easier to see that this number is definitely smaller than this number, and the difference between these two numbers is bigger than the errors that we're seeing. One thing to point out also that this last estimate for the 2010s, that's got a much larger uncertainty for it, and that's because we've got much less data for that year. It's only over 4 years rather than over 10 years. So we're getting some uncertainty in our gradient of the long-term average from these kind of annual cycles in the data. But still, we can still see that it's an increase in rate of rise compared to the beginning of the century, beginning of the 60s, the beginning of the record in the 60s than in the kind of 2000s. But we can't really say that the 2010s are any different to the 2000s. These two numbers are effectively the same because their error on the estimates overlap. So the table is one way of showing this. Another way of showing it might be a plot of some sort. So we could maybe plot the time. In this case, these are actually just words because I put an S for 70s. Make a plot. I could insert a plot. Let's just insert a standard bar chart even. Okay, so we could now we've got a bar chart. We could add our error bars to that. So we could add error bars. Okay, we could then go and change those to our, for the skyscraper here, we could change those to our specific values, specify those values, and we've calculated them, so we'll just put those in. Click OK. So we can now see kind of graphically, obviously you'd want to put some axis titles on this. I mean, in this case, this is maybe one of the cases where the grid lines might be helpful, because they might help us see, is this really different to this or this? So we might want to add more grid lines so we could see if these errors, do they actually overlap or not? Okay, so let's do that. Let's increase the density of our grid lines. So we could so we've got major grid line options here. So we could think about our what do we want to add? We want to see if we can add chart element, grid lines. We've got major horizontal. Okay, that's what we had already. Okay, we've got major vertical ones. We don't really need vertical grid lines. We might want some minor ones. Okay, so we put the minor ones in there, and that's put grid lines into. I'll just give this some bigness. We can't really see those, so let's just change those so they actually have some. Okay, we've got them in black, so we can actually see them. Maybe not black, but maybe a subtler grey. Okay, so we can actually And if you're going to do that, you need to make your error bars more obvious. So again, we can play around with those. Let's put them in blue and give them super thickness. Okay. Yeah. So again, the task for this part of the practical is for you to play around with this plot. You might want to combine a plot like this with a plot like this. Ooh, on top of each other, to show how CO2 changes through time and how the rate of CO2 rise changes through time. Okay, you want to think about how you combine those together. So hopefully this tutorial has helped you at least find out how to make some of the plots that are that are required for this tutorial. How we can make kind of nice looking graphs that actually are designed to show a specific aspect of the data, whether it's the annual cycles, the long-term trend. I mean, for example, with this one here, we could modify this if we were doing a discussion on the annual cycles. Okay, we could actually zoom in kind of just on a short period rather than the whole record to show those annual cycles. So we could just zoom in by changing the horizontal axis here to say just 2004 to 2010. Let's do that, 10. Okay, where we can now see the annual cycles a little bit more clearly. We might think about separating these out a little bit more by changing the vertical scale. So we might change our vertical scale. Okay, so we might want that to go to only up to 390 maybe. Okay, maybe that was a bit too much, but we could change the oh, that was it? Yeah, so let's change the minimum down to 330. That. Okay, so we can see. So now by manipulating this vertical scale, we might also want to change the spacing of the tick marks and how big they are apart. So the major units we might now want to actually just be 5. Okay, put those in like that. We might want to change the ocean pH axis so they don't overlap so much up here. So they're kind of one above the other. So we could do that by making this number a bit bigger. 4. That moves it down a little bit. So now we've got quite a nice plot that shows the annual cycle in CO2, the annual cycle in pH, and you can see that they're kind of opposite each other, but kind of, I guess, similar, annual periodicities. Okay, so do play around with your data like this. I guess at this scale, you can see that this moving average trend line, that's clearly misleading us a little bit there. But I guess we're also being misled by our thing being shifted, trend line being shifted in the pH data. So a little bit of a criticism of the way Excel does it. There is another way of doing it, which involves you doing all of the calculations to work out the manual moving average manually, I guess. Okay, so I'll finish there. The task is for the assessment is for you to write a report about this. So it says using appropriate. Oh, all the instructions are in the back of the handout, really. But so you've been given these data, the CO2 and the pH. So you need to write a report about those two. Why are they, going up or going down? What's causing them to one to change in conjunction with the other? And then to use some of the plots that we've made in the tutorial, and maybe some of your own, to illustrate that report. Okay, so we're going to stop there.